Okay, here we've got a stereotypical ladder problem. Ladder leaning against the building. The ladder is 25 feet long. The vertical distance is labeled as R. I labeled the horizontal distance as X. And the bottom of the ladder is sliding out at a rate of 2 feet per second. We're wondering at what rate is the top of the ladder sliding down in 3 different instances. I'm just going to do one of them. I'm assuming that if I get one of them, you could follow that model to get the other 2 answers. So in this case, we have a general equation of the Pythagorean theorem. So this is x squared plus r squared is equal to 25 squared. And notice in this I plugged in 25 right away because that's a constant value in the problem. The length of the ladder never changes as it slides down the building. So I can put that in right away. Taking the derivative here, I get 2x dx dt. Remember, we're taking a derivative of x with respect to time, so you need a dx dt. The same is true for r, dr dt gets stuck on the end of that. And of course, the derivative of a constant is plain old 0. Okay. Now, looking at this, I have 4 unknowns there, x, r, dx, and dt. I was given dx dt at the beginning of the problem. And for the first part, I know that x is equal to 7. I'm solving for dr dt, which means I need to figure out what r is. In order to figure out r, I'm going to do a little sidebar over here and go back to the original problem. At that snapshot in time when x equals 7, I get the following equation. 7 squared plus r squared is equal to 25 squared. Okay. Which, doing the math, we magically find that r is equal to 24. It's an old Pythagorean triple there. 7, 24, 25. Okay. Now I should be good to go. I should know all the information that I need for this problem. It's a matter of plugging and chugging. I get, let's see, 2 times 7, and dx dt is 2. Notice that 2 is a positive value because x is getting bigger as the problem goes on. 2 times the radius, or not the radius, the r threw me for a loop. The length r is 24, and we're looking for dr dt. And the 0 is still the 0 there. So that gives me 28 plus 48 times dr dt is equal to 0. And therefore, dr dt would equal negative 7/12 feet per second, which is actually about negative 0.583 feet per second. And you'll recall in the 9-step method I said, check to see if your answer makes sense. And I will say the one thing about this problem, I don't really know if negative 7/12 is a good value, but I do notice that the value is negative, which makes me happy because the top of the ladder is sliding downward. The value of r is getting smaller, and therefore my rate of change of that value should be negative.